Hello everyone and welcome back. Today we'll be looking at question 2. So Rachel had just opened her new computer store. She makes $27 on every computer she sells and her monthly expenses are $10,000. Write an algebraic expression to represent this relationship using a variable. Use this expression to find the minimum number of computers she needs to sell in a month to make a profit. If she were to make a profit of $1,200 in a month, how many computers would she need to sell? Make sure you justify your answer clearly. So now you guys can pause the video and try to solve this question by yourself. Hello guys and welcome back. So we can know that each computer can make her $27 and the total expenses for them is $10,000. So because the number of computers she sold can change, so this is the variable for the algebraic expression. So we can say that she sold in computers in total. So the money she made in total is $27. For example, if she sold 3 computers, then N is equals to 3. So she can get 3 multiplied by $27. And because the expenses for the total computer is not changing, so we can make that, so she will earn equals, this is earn, so she will earn the profit she make minus by expenses. So we can make that earn is equals to made expenses, and then we just need to take this expression into, so earn is equals to 27M minus by 10,000. So this is the algebraic expression that the first question is asking for. So now let's look at the second question. So the second question is basically asking what is the minimum number of computers she needs to sell in a month to make a profit. So because it is to make a profit, so the profit is equals to the money she earns, E. And because you need to make a profit, so the number of the profit must be bigger or equals to 0. Also, don't forget that it is asking the minimum number of computers, so the profit must be minimum. So according to the formula or the algebraic expression we made in the first question, we can easily get that 0 is equals to 27M minus by 10,000. So now we just need to solve this equation. So what do we do is that we move the 10,000 from right side to left side. So we can get 10,000 is equals to 27M. And then we just divided 2 sides by 27. So we can get N is equals to 10,000 divided by 27. And then you just need a calculator to calculate. So you can get N is equals to 370.37. It's approximation. Okay, but it's asking the minimum, and the number of computers that sold must be an integer. So now the N must equals to 371. Because if the number of 370 is not enough to make a profit, so we must take 371, so the integer that is bigger than this number. Okay, so now let's look at question 3. So the question 3, okay, so now let's look at question 3. So question 3 is asking that how many computers were sold in order to make a profit of $1,200. So from question 1, we already know that profit is equals to 27n minus by 10,000. So, and because the profit needs to equals to $1,200, so we can easily get the algebraic expression that $1,200 is equals to 27n minus by $10,000. And then we just need to solve this equation. So it's just almost the same steps. So just move this 10,000 over. So it's $11,200 equals to 27n. And then you just divide it by 27 to each side. So it's 27 divided by 27n. And then this side is 11,200 divided by 27. Now we can get in. You just need to calculate by the calculator. You can get n is approximately equals to 4,014.82. And because the number of computers that show must be an integer. So now we can only get n is actually equals to 415. So this is the final answer. So this question requires the students to find an algebraic formula and input numbers to the formula in order to find out the question. This will be a level 5 and 6 question in the test. And that's it. Thank you for listening and good luck.